Okay, so let's get started with type conversion and casting. Right. Okay. Type conversion and casting. If you have previous programming experience, then you already know that it is fairly common to assign a value of one type to a variable of another type. If the two types are compatible, then Java will perform the conversion automatically. Alright. For example, it is always possible to assign an int value to a long variable. However, not all types are compatible and thus not all type conversions are implicitly allowed. For instance, there is no automatic conversion defined from double to byte. Fortunately, it is still possible to obtain a conversion between incompatible types. To do so, you must use a cast which performs an explicit conversion between incompatible types. Between incompatible types, let's take a look at both automatic type conversion and casting. Okay. We move on to Java's automatic conversions. When one type of data is assigned to another type of a variable, an automatic type conversion will take place if the following conditions are met. The two types are compatible, the destination type is larger than the source type. Okay. When these two conditions are met, a widening conversion takes place. For example, the int type is always large enough to hold all valid byte values, so no explicit cast statement is required. For widening conversions, the numeric types including integer and floating point are compatible with each other. However, there are no automatic conversions from the numeric types to char or boolean. Also, char and boolean are not compatible with each other. As mentioned earlier, Java also performs an automatic type conversion when storing a literal integer constant into variables of byte short. Yeah, right. Alright, so now we move on to casting incompatible types. Although the automatic type conversions are helpful, they will not fulfill all needs. Okay, let's move it a bit here. They will not fulfill all needs. For example, if you want to assign an int value to a byte variable, this conversion will not be performed automatically. Because a byte is smaller than an int, this kind of conversion is sometimes called a narrowing conversion. Since you are explicitly making the values narrower, so it will fit into the target type. Okay, widening conversion if the source is bigger size than the target. Then we move on to to create a conversion between two incompatible types, you must use a cast. A cast is simply an explicit type conversion. It has this general form. Here, target type specifies the desired type to convert the specified value to. For example, the following fragment casts an int to a byte. If the integer's value is larger than the range of byte, it will be reduced modulo the remainder of an integer by the bytes range. Okay. Takes the modulo with the bytes range. A different A different type of conversion will occur when a floating point value is assigned to an integer type, truncation. As you know, integers do not have fractional components. Thus, when a floating point value is assigned to an integer, the fractional component is lost. For example, if the value is 1.23 is assigned to an integer, the resulting value will simply be 1. The 0.23 will be truncated. Of course, if the size of the whole number component is too large to fit into the largest integer type, then the value will be reduced to the modulo of target's type range. Okay. Modulo. Okay, so let's we byte, int and a double. So byte, it takes value in modulo 256, it should be 1, right? Then we I to int of d, it will be 323. Then we go byte to d, 323 modulo 256. What will it give? Whatever, 67. Okay. So let's go here. Right. It is still recording, right? Right. Yeah. Okay. So I'll quickly type it in. Java GitHub. There you go. Type conversions. Here we will create a new file called conversion.java, and I want to open it up. Okay. Let's close everything to the left, and then we demonstrate cast. Okay. So let me keep the book aside. Well, how am I going to see? Demonstrates cast conversion. Then the main function. Then let's make a byte p, an int with value 257, and a double value double t equals, it was 323 dot, let's suppose that's I don't. Then we have system.out conversion of int to byte. Okay, then we go byte, and then we go I and p. So system.out.print int to byte. Then I want to assign p, this is explicit cast I, then then we go print line I and P are I plus P, and we add a new line, right? Then we go system.out.println conversion of, what is this? Conversion of double to int. Conversion of double to int. So we go I equals int d. System.out.println, we get d and I are plus d plus empty space plus I plus new line. There you go, conversion of double to byte. We go B equals byte D. D and B are, we got D plus B plus, and that's about it. Right? Okay, print line. Okay, so they have added in the front. Okay, so we run it. Go clear Java C. Okay, expected. Where did I forget to put a semicolon? Semicolon, not semicolon. Yeah. Okay. Java 11. Print line. Statement plus. Oh, okay. I forgot the plus. I forgot the plus anywhere else. I don't think so. That's all there is to it. Java conversion. Okay. So is 1, 63, and 67. Okay. So set. We move on here and we get to camera. Alright, then we come back here and we see the output, then we move here. Okay, so let's look at each conversion. When the value 257 is cast into byte variable, the result remainder division of 257 by 256, just 1 in this case. When d is converted to int, its fractional component is lost, and when d is converted to byte, its fractional component is lost and the value is reduced to modulo 256, which is 67. Right. Okay, then we move on to automatic type promotion in expressions. In addition to assignments, there is another place where certain type of conversions may occur in expressions. To see why, consider the following in an expression. The precision required of an intermediate value will sometimes exceed the range of either operand. For example, Okay, so we have byte, then we multiply, so A and B, it gives 4 is the 200. It's a 0. Okay, 20. It will be 2000, right? Okay, we go in expression. In an expression, the precision required by an intermediate value will sometimes exceed the range of either operand. Okay. So we have a byte 4050. Then when we multiply into B, its result is 2000, which simply exceeds the range of a byte, which is 250, 0 to 255. The result of an intermediate term a times b easily exceeds the range of either of its byte operands. To handle this kind of problem, Java automatically promotes each byte, short, or char operand to int when evaluating an expression. Okay. This means that the sub-expression a times b is performed using integer, not bytes. Thus 2000, the result of the intermediate expression, is legal, even though a and b are both specified as byte. Okay. As useful as the automatic promotions are, they can cause confusing compile time errors. For example, the seemingly correct code causes problems. Okay, error cannot assign an int to a byte. Right. So because in expressions, byte is promoted to an int, therefore we cannot assign an int, because that would be narrowing, and narrowing is only done with explicit cast conversion. The code is attempting to store 50 perfectly valid byte value back into a byte variable. However, because the operands were automatically promoted to int when the expression was evaluated, the result has also been promoted to int. Thus, the result of the expression is now type int, which cannot be assigned to a type byte without the use of a cast. This is true even if, as in the particular case, the value being assigned would still fit in the target type. Right. In cases where you understand the consequences of overflow, you should use an explicit cast, such as this. Okay. Then we move on to type promotion rules. Java defines several type promotion rules that apply to expressions. They are as follows. First, all byte short char values are promoted to int, just as described. Then, if one operand is long, the whole expression is promoted to long. If one operand is float, the entire expression is promoted to float. If any of the operands are double, the result is double. Okay. Then we move on to, maybe I should fix this here. Okay. The following program demonstrates how each value in the expression gets promoted to match the second. See, right. Double result if we have a D in there. Let's look closely at type promotions that are in this line. Right. FP is promoted to a float because F, I and C promoted to an int and the result type int. Then D and S is promoted to double, then the type of sub-expression is double. Finally, these three intermediate values float into are considered. The outcome of float plus int is a float. Then the resultant float minus double is promoted to double. Right. आशु भाई सिरप देना, ये पीने की सिरप सिरप। Okay. रन। उसने वो कर दिया। Okay, then we move on to arrays. What are arrays? An array is a group of like-typed variables that are referred to by a common name. Arrays of any type can be created and may have one or more dimensions. A specific element in an array is accessed by its index. Arrays offer a convenient means of grouping related information. Okay. Then we have different types of arrays. Yeah, one-dimensional array. A one-dimensional array is essentially a list of like-typed variables. To create an array, you first must create an array variable of the desired type. Here type declares the element type, also called the base type of the array. The element type determines the data type of each element that comprises the array. Thus, the element type for the array determines what type of data the array will hold. For example, the following declaration array named month, days with type array of ints. Okay. Although this declaration establishes the fact that month days is an array variable, no array actually exists. To link month days with an actual physical array of integers, you have to do something. New int then size of array. Go. You must allocate one using new and assign it to month days. New is a special operator that allocates memory. Right. New operator. Then we have you will look more closely at new in a later chapter, but you need to use it now to allocate memory for arrays. The general form of new as it applies to one-dimensional array is this. Okay. Here type specifies the type of data being allocated, size specifies the number of elements in the array, and array_var is the array variable. Array_var is the array variable that is linked to the array. That is, to use new to allocate an array, you must specify the type and number of elements to allocate. The elements in the array allocated by new will automatically be initialized to 0 for numeric types, false for boolean, or null for reference types, which are described later in the chapter. Okay, so they are automatically zeros or false for booleans. Okay. Then we go. After this statement executes, month underscore days will refer to an array of 12 integers. Further, all elements in the array will be initialized to 0. Let's review. Obtaining an array is a two-step process. First, you must declare a variable of the desired array type. Second, you must allocate the memory that will hold You must allocate the memory that will hold the array using new and assign it to the array variable. Thus in Java, all arrays are dynamically allocated. If the concept of dynamic allocation is familiar, okay, so all arrays are dynamically allocated. Right. Then we move on to, once you have allocated an array, you can access a specific element in the array by specifying its index within square brackets. All array indexes start at 0. For example, this statement assigns the value 28 to the second element of month underscore. The next line displays the value stored at index 3. It will be 0. Putting together all the pieces, here's a program that creates an array of number of days in each month. Okay. So you will go ahead and create this. Okay, alright. Go arrays. Then we will create a new file called array.java. Let's open it up. So demonstrates one-dimensional array. Right. So we first create a array variable month days, then we allocate this variable then we can assign value. Okay, so 1 2 3 4 5 6 7 8 9 10 11 12. Okay, then we can print something like system.out.println April has days. Okay, right. We move on to a scene. When you run this program, it prints the number of days in April. As mentioned, Java indexes start with 0, so the number of days in April is month of 30. Month of 3, which is 30. It is possible to combine the declaration of array variable with allocation of array itself, as shown here. This is the way that you will normally see it done in professionally written Java programs. Professional. Arrays can be initialized when they are declared. The process arrays can be initialized when they are declared. The process is much the same as that used to initialize the simple types. An array initializer is a list of comma separated expressions surrounded by curly braces. Okay. The commas separate the values of the array elements. The array will automatically be created large enough to hold the number of elements you specify in the array initializer. Okay. Right. There's no need to use new. For example, to store the number of days in each month, we can also do this. Okay. When you run this program, you see the same output that is generated by previous version. Java strictly checks to make sure you do not accidentally try. Java strictly checks to make sure you do not accidentally try to store or reference values outside of this range. The Java runtime system will check that all array indexes are in the correct range. Okay. So let me try auto arrays real quick. Improved version of the previous program. Okay, then we go to end month days and we use a list initializer. Sorry. Here we go. 31, 31, comma 28, comma 31, comma 30, comma 31, comma 30. Comma 31, comma 31, comma 30, comma 31, comma 30, comma 31. And then we simply use this. So it will automatically allocate say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 as an array of size 12. Okay, so let's compile. Yeah, okay. So it gives me an error, and sorry, I should add that, and then there's 30 days, right? Okay, then we move on to camera again. Okay. Okay. For example, the runtime system will check the value for each index into month days to make sure that it is between 0 and 11 inclusive. If you try to access an element outside the range, negative numbers or numbers greater than length of array, you will cause a runtime error. Okay. Here is one more example that uses one-dimensional array. It finds the average of a set of numbers. Okay, so we have this average, public static void main, we double nums, we have this, then double result is 0. Okay, int I, then we define an integer I, then we use a loop for I equal less than 5, because result equals to result plus, sorry, you probably can't see. Okay. Then we go with for I equals to 0, I less than 5, start with result equals result plus, so it adds numbers 1 by 1 into result, then we result divided by 5 to give the average. Then we have multi-dimensional arrays. Multi-dimensional array. In Java, multi-dimensional arrays are implemented as arrays of arrays. This is important. To declare a multi-dimensional array variable, specify each additional index using another set of square brackets. Okay, for example, the following declares a two-dimensional array with 4 rows and 5 columns. This allocates 4 by 5 a 4 by 5 array and it assigns it to 2D. Internally, this matrix is implemented as an array of ints. Conceptually, this array will look like the figure shown, looks like the one shown in 3.1. Okay, so let's see that. Right, so let's take a look at this figure. So we have 1, 2, 3, 4. We have 4 arrays, each containing, so we have 4 arrays and each array have 5 elements, right? Okay, so we demonstrate a 2D 2D array. So we make 4 by 5 I, j and k. Okay, for j is equals to 0, 2D of k. Okay, then we print it. There are 2D elements. Okay. So let's okay, so let's implement this. Okay, this is demonstrate a two-dimensional array. Demonstrates a two-dimensional array. So we go class 2D array. we make a 2D array of size 4 by 5, and what is this? 2D equals new int 4 5. Then we declare some variables int I, j and k, which we set initially to 0. Then we want to loop through the arrays and we want to assign the values equals to k, and then we increment k. First we assign values to the 2D array, to the 2D array elements. Then we display the value of 2D array elements. J plus empty space, then we print a new line here. And this should look something like this, right? So we get, so when you allocate memory for a multi-dimensional array, you need only specify the memory for the first leftmost dimension. You can allocate the remaining dimensions separately. Ooh, this is important. Okay, so for example this code this following code allocates memory for the first dimension of 2D when it is declared. It allocates the second dimension separately. Nice. Well, there is no advantage to individually allocating the second dimension arrays. In this situation, there may be in others. For example, when you allocate dimensions individually, you do not need to allocate the same number of elements for each dimension. Right. As stated earlier, since multi-dimensional arrays are actually arrays of arrays, the length of each array is under your control. The sizes in the second dimension are unequal. Okay. So we get this 2D again, manually allocate differing size dimensions. Okay, so we get four outer arrays, then we size 1, then second size 2, third size 3. Okay, Okay, so it uses I plus 1, right? Okay, I plus 1, same. Okay, let me take a look. Code. Okay, since the preceding sizes increase by 1, for the next arrays we set the upper bound of j equals to I plus 1, right? The program generates the following output like this. The array created by this program looks like this: 0 0 1 0 1 1 2 0 2 1 2 2 and this. Okay, then we move on to the use of uneven or irregular multidimensional arrays may not be appropriate for many applications because it runs contrary to what people expect to find when a multidimensional array is encountered. However, irregular arrays can be used effectively in some situations. For example, if you need a very large two-dimensional array that is sparsely populated, that is, one in which not all the elements will be used, then an irregular array might be a perfect solution. Okay, sparsely populated, right. Okay, then it is possible to initialize multidimensional arrays. To do so, simply enclose each dimension's initializer within its own set of curly braces. Dimensional arrays. Alright. The following program creates a matrix where each element contains a product of the row and column indices. Okay. Also notice that you can use expressions as well as literal values inside array initializer. Okay, these are just like regular initializer. Okay, so let me program it 2D again first. Manually allocate differing size second dimensions. So we have manually allocate differing size second dimension. Okay, so we have class 2D again. Public static void main string args. Then we create int 2D new int of 4. Right, then I can go 2D of 4 comma 0. Okay, 0. Then this will be new int of size 1, right? 2 3 and 4. 3 2 and 1. Am I right? Yes, I'm right. Okay, so I also need this because it means that we are going to define a two-dimensional array. Okay, then when we can simply use a do and I equals 0 j and k equals 0. I think all are default initialized to 0. Right? They must be default initializers. I must have seen type conversion, local variable, variable declaring a variable, dynamic initialization, declaring a variable, identify variable, we can initialize equal to sign. Keep in mind the initialization method of compatible type specified to declare variable. Whether you choose a non-initializing in the name, dynamic initial string literals, point literals, initializations. Do we have initializations? Well, I think they are default initialized. Positive, so see manage meaning high order bit. Okay, the width, behavior, Java. Okay, so it does not tell anything. And okay, it's employed this institution. Equivalent. I think they are default initialized to the equivalent of zeros. Floating point literals. I like the bytes. Neutral variables. Okay. A variable is defined by a combination of identifier type and an optional initializer. In addition, all variables have a scope which define the visibility. Okay, declaring a variable. Identifier, name of the variable. You can initialize variables like you can mind initialization. Dynamic initialization. Scope. Okay, what is the value? Okay, I think initialization must have initialization. I think polymorphism entering the program. A second short program. Declare the variable. Right. Creating a variable. Assign the value. If variable change during the next variable change during execution. What are the default values? Does it talk about default values? Lexical issues, separators. It does not talk about default value. I think the default is equivalent of 0. $32. Right. Within a block or whatever, the default value is always 0. All declarations in Java default to 0, I think because it's a module 8 type by the long mismatch I can just quickly check that, There we go. Okay. Variable might not have been initialized. Okay. So uninitialized variables, okay, so it does not allow access for uninitialized variables. You need to have a value, right? Great. So I was here, right? So we go for I equals 0, I less than 4 plus plus then we go for j equals 0 and j is less than I plus 1, and then we increment j and then we assign values I j equals k. I can just go plus plus. Assigning values, and we go with displaying values. So for I equals 0, I less than 4, I plus plus, j equals 0, j less than I plus 1, and j plus plus. We do I plus 1 because the succeeding array has a size 1 more than the preceding array. So initially it is 1, so I is 0, 0 plus 1 and so and so on. Print, we go to d I comma j plus this, then we add a new line here. Get this. Alright, so that's it for today, people. We call it a day now.